Hello everybody, welcome back. We have a bell ringer to get started with, so if you would please pause the video and work through these questions and then start back and you'll have a second part to this bell ringer. Okay, so if we're evaluating this logarithm here, we start out, set it equal to x, and then we check mark it. So we're going to have 12 to the x equals 7, and that didn't really get us anywhere. So if you're thinking about how to do this, then you could actually just do change of base formula. So log of 7 over log of 12. Remember, we're using common logs to evaluate this, and then you're just going to put that in your calculator. So log 7 divided by log 12, you will get about 0.78. We'll do 3 decimal places, 783. Okay? So remember, it's log of the big number divided by log of the little number. Alrighty, so the next one here, log base 3 of that equals log base 3 of that. So if we have the same logarithm on both sides, if there's only one over here and only one over here, then we can cancel those, okay? And then we can just kind of use the information that we have left. Alright, so since we have an x squared and an x in this equation, we're going to have to put everything on the same side and factor. So we're going to move that 4x over. Okay, those don't subtract because they're not like terms, so we just write everything out. Like so, and now we're left with two numbers that multiply to 12 and add to 4. So that's going to be 6 and 2. Alright, so our answers are x equals 6 and x equals 2. So we set both of those equal to 0. That's a zero product property. Okay, and then you double check them. So that should keep us a positive there if we plug those two in, and that'll keep us positive here. So they should both work. Alright, and then the last one, we have an e here. Okay, so remember, we want to isolate the exponential. So add 3, we'll have 5e to the x equals 3. Divide both sides by 5. Okay, and now we have e to the x equals 3/5, and now we're looking to get that exponent. We have an e here, so remember, we can take natural log of both sides. That'll cancel out the e. We get x equals natural log of 3/5. I'm okay with you leaving that as an answer. However, you might have put it in your calculator. So if you did, then you got a negative 0.511. Okay. This is going to be the best answer because this one I had to round off. So at this point in time, we're going to be looking at our tests. Okay, so I'll have to sub-pause the video when I'm done reading this stuff here. Okay, so just like normal, look over your test, look over what you did wrong. If you want to retake the test, then you can keep it and you can work on your corrections. Okay, so remember, you need to make corrections with written explanations, and I need to look over those corrections before I allow you to retake the test. So you can't just come up to me and say, here's my corrections, when can I retake it? I need to have time to look over your corrections to see if you did them right. Okay? You can use your resources, you can use your notes, you can use whatever you want to make corrections, but you have to understand what you're doing, because remember, a retake can also drop your grade if you do worse. So make sure you know what you're doing, make sure your corrections are correct, and make sure that the methods stick in your head. Okay? Second part here, retake should be taken in one sitting, which will take some time after school. Plan for about an hour. That's usually about how long my tests take. Okay? Make sure your coaches are aware if you're going to retake a test. If they need to email me, they can. Or if you need me to email them, I can do that as well. Remember, you're a student athlete, so it's important that you take care of the student part before the athlete part. Okay? There's one person in first hour and a couple people in third hour that haven't taken it or haven't finished it. There's actually a couple in first hour. So those people should not be looking at the tests. Okay, they need to finish it, and those people that need to finish it, you can finish your test today in study group. So you'll have to go after school and request that from whoever is leading study group. Finish that during that time frame, and then I'll come and pick it up later today and grade that. Okay? So please pause the video, give students a chance to look at their tests, and please pass out their tests. And then we'll start with the second part of the bell ringer. So This chapter we're going to be working with fractions with variables in them. They're going to kind of look like this, possibly a little more complicated, but we're going to be working with addition, subtraction, multiplication, division, and all those good things with fractions. Today will be multiplication and division, as you'll see on the next slide, but we're going to start with a warm-up here. So please pause the video for, let's say, 3 minutes and go ahead and see if you can solve these. Okay, so multiplication with fractions. The first thing you want to do is try to cross cancel, right? So the 2 and the 6 here can cross cancel. I can divide a 2 out from those. And then the 3 and 4 stay the same. So now I'm just going straight across after I cross cancel. So 1 times 4, I get a 4. And then 3 times 3, I get a 9. Okay, for people that don't like cross canceling, another option would be to just multiply straight across right away. Okay, so if we multiply straight across, we'll have 8 over 18, and then you're still going to have to simplify this out by taking out that common term. Okay, so then you would divide both of these by 2 to simplify it, and we would end up getting the same answer. Okay, division. If you were at Seward Middle School, remember they teach skip, flip, multiply. That's what they teach down there. So you skip the first fraction, flip the second fraction, so you're going to work with the reciprocal here. And now we're multiplying, so we're going to cross cancel or go straight across. I like to cross cancel, makes things a little bit easier. Okay, so 5s cancel out, those both turn into 1s, and then we're left with 10 over 3 when I multiply straight across. Okay, so we get 10/3. Alrighty, over here, we're solving for x. Okay, we're solving for that variable. How do I get rid of the 3/4? Okay, well, there are a couple different ways. You can multiply by the reciprocal, right, on both sides, multiply by 4/3. That's probably the best way that you've done it. So you get 20 over 18. And you see that we could have cross-canceled there a little bit. So that would turn into a 2, and that would turn into a 3, so you'd have 10 over 9. Get x equals 10/9. Okay? Another way is going to be dividing by a fraction. Okay? And I know you're always taught that you don't want to divide by a fraction. Okay, but we're going to be working with that stuff this chapter. So if I divide by 3/4, right, those would go away. So when we divide by that 3/4, that creates a complex fraction. So that's 5/6 divided by 3/4, but we just did a fraction over a fraction here, right? So we skip, flip, multiply. So if we flip that bottom one, and we're going to multiply. And then you can see that we would end up getting the same thing. We get 10/9. So if we cancel, or it'd just be the same thing as multiplying by the reciprocal. Okay, last one right here. We haven't done one like this before, but we definitely can do it. Okay, so what you need to do when you start these is factor. So this factors to x minus 1, x plus 1. And then you see that I have a similar factor on the top, the numerator, as I do the denominator. Those will cancel out, and I'm left with x minus 1. Okay. So that'll lead us into the lesson today. So we are going to be multiplying and dividing rational expressions. And rational expressions, that's a fancy way to say fractions. Okay, I know that a lot of people don't like fractions, but we're going to get pretty comfortable working with fractions through chapter 7. Okay. So, we kind of did this already. So multiplying and dividing rational expressions, we first start out with just simplifying them. Okay, so that's what we're starting with, simplifying. And what this property here is saying, if I have a times c divided by b times c, I have a common factor, c, that'll cancel out, and I'll be left with a over b. Okay, so we can kind of look at this, and I'll show you, you don't have to write all of this down, but I'll show you what the property looks like if I'm just using regular numbers. We know that 15 is 3 times 5, and we also know that 65 is going to be 13 times 5. okay? Or if you thought about it even easier, you knew that you could take a 5 out of both of those, right? If I take a 5 out of the 15, I'll be left with a 3. If I take a 5 out of the 65, I'll be left with a 13, okay? So this is the way you write it out using that property, and you see that the 5's will cancel, and I'll be left with 3 over 13, that wonderful fraction there. Okay, so when we simplify rational expressions, those are going to have more variables in them. This is just a basic fraction. What we're going to be working with will look something like this, where we have variables. Okay, so in order to start a problem like this, you want to factor everything as much as you can. Even though we can kind of see things cancel out right away, we want to factor things as much as we can. Okay? So, after you have this written down, factor everything out as much as possible. So, the top, I can't do anything, so that just stays as is. The bottom, I can leave this one, and then this one right here is going to factor. So I have y minus 3, y plus 3. Now that didn't really help us cancel much out, but I'm going to show you why we did that. Okay, so when we simplify it, we can see that that will cancel with that. Now you might want to cancel that 3 with these, but you can't do that because there's a plus and a minus in those, and that doesn't really allow you. You can't just take the 3 out since there's a addition subtraction. Okay, so after we simplified it down, we have this rational expression that we're done with. Okay, and now there's this information down here, or this question down here. Do we have domain restrictions? If you remember back to last chapter, domain restrictions are when the bottom equals 0, because we don't want the bottom equal to 0. So we have to think about the things that would make that equal to 0. And now we also can't forget about our original here. Okay, so this is the one that we want to look more at. Okay, so maybe we want to look at just this one or the original. And if you look at the way I factored it, this is much easier to see the zeros than the original. Okay, so we want to factor everything out completely and then look for those domain restrictions. So this is the one where I factored everything out completely, so my domain restrictions I can easily see here. So I'll say y cannot be equal to, what would make this a 0? A negative 7. What would make this one a 0? A 3. What would make this one a 0? A negative 3. So those would be my restrictions in this scenario. Now I know it's y and I said domain, so essentially just what are the restrictions in the equation. We cannot have these 3 values because they would create a 0 in the denominator, which would not work. Okay, so let's look at a question down here. Let's give this one a shot. So please pause the video, have students write this one out, and then play for the solution. Alright, so I'm not going to rewrite this one out just because it takes extra time to write it out. We're going to take this one, factor it. Okay, so this is the difference of squares again. We have a perfect square of 16 and an x squared. So it'll be x minus 4, x plus 4. And then we can cancel out this binomial with that binomial, and our simplified answer will be x over x minus 4 times x plus 4. And then we need to list our restrictions. Okay, it should be pretty simple. If you have something that's fairly nice like this, x can't be a negative 5 or a 4 or a negative 4. So you have 3 restrictions in this equation. Okay? So if we're continuing simplifying here, this one might be a little more advanced with factoring. Some things that you need to do. So you factor everything completely. If you look at this one right here, your brain might say, oh, I got an x squared there and an x squared there. I can just cancel it out. I cannot do that, remember, because a plus or a minus really kind of messes stuff up. So you want to factor completely, and then we can divide out any common factors or binomials. Okay? Always start with this. You always factor completely first. Okay? You can't just cancel this and be left with 7x because it doesn't work that way. Alright, so what does this look like after we factor it? We have our numerator here, x squared plus 7x. There are no special patterns for this one, right? Because we have an x squared there and an x there. However, we want to look for a common factor. So it'd be x times quantity x plus 7 over x squared. Okay, now we can look to cancel stuff. Since we have this x times quantity x plus 7, these are two things that are multiplying together, then I can cancel out this x with one of those. Just because I have x times this stuff. I can't cancel it with that because there's x plus that. Okay, so we're going to go ahead and cancel out one of those. So that cancels and brings that down. And then we're left with x plus 7 over x. Okay, and again, since we have a plus there, I cannot cancel anything out. I have to leave it like that. So that's it. Whenever you have multiplication, then you can cancel stuff out. Or like whenever you have division, you can cancel stuff out, right? We can't just cancel when there's addition subtraction. The only way you can do that is if there's a negative, which you can't just throw a negative in there. Okay, so let's look at another one. All right, so go ahead and write that one down. If you wanted to save yourself a little bit of time, I would recommend writing it down in factored form. So at this point in time, we should be able to factor these polynomials, like this trinomial and this binomial. You should be able to factor that in your head. Okay, so I'd recommend saving a little bit of paper, a little bit of ink, writing it down in factored form first. All right, so two numbers that multiply to 15 and add to a 2. Okay, that's going to be a 3 and a 5. So I'll have x minus 5 on the top and x plus 3 up there. Right, so negative 5 times a 3, positive 3 is a negative 15, negative 5 plus 3 is a negative 2. That's the numerator. Denominator, x minus 3, x plus 3. Now you should see we have a common binomial right there. Those cancel out. And we're left with x minus 5 over x minus 3. And that is it. Okay, so really with these problems where you factor everything like this, you're looking for the same thing in parentheses and those will cancel out. Now, if it asks for restrictions, it doesn't always ask you for restrictions. If it does, then remember you look at your factored form in the denominator, so x cannot equal 3 or negative 3 in this case. Okay, there are specific problems that ask for restrictions. If it's just basic simplification problems, you factor, simplify, and you're done. All right, let's try one more down here. So this one we're looking for some information about the restrictions. When or for what values of p is undefined. This is just another way to ask for restrictions. Okay, so go ahead, factor this, and see what cancels out, and then write out your domain restrictions or your restrictions in the problem. So pause the video, allow students some time to do that, and then press play for the solution. Okay, so back at it, the top, we'll factor to a 3 and a 2. Okay, 3 times 2 is 6, 3 plus 2 is 5. The bottom is going to factor to a 5 and a 3. Okay, and then that will cancel with that, so we'll have p plus 2 over p plus 5. That's our solution. If we're looking for restrictions, we're going to have p cannot equal negative 5 or negative 3. Okay, so really the question was just looking for these restrictions. I didn't need to do this part, but it's good practice. All right, so multiplying. We already had a little bit of warm-up practice on these. So we're going to jump down to the fractions here, okay? If you wanted to write this down, you can. Multiplying is the same as multiplying fractions, okay? With multiplying rational expressions, I recommend just simplifying the numbers, okay? So those would be called coefficients. If you can cross-cancel, I would cross-cancel the coefficients, and then we're going to just multiply straight across. So if we're looking at this one here, all right, we'll call that problem 1, problem 2 down here. So we're going to cross cancel. So that would turn into a 2, that would turn into a 1, and I just took a 4 out of both of those, right? Just like basic fraction simplification. You can cross cancel diagonally, and then you can also look here vertically, because that's just 2 over 2. 2 and 7 aren't going to cancel, but I can cancel those out, and then I'm just left with something that's much easier. Okay, so we're just going to go straight across with those variables. Remember what we do when we multiply like variables. So x to the third, x to the fourth, we're going to add those together. We'll have x to the seventh. Okay, that y has an exponent of 1. So we'll have y to the first times y to the third, give me y to the fourth. So those are my exponents. On the bottom, I'll just have an x, y cubed. And now I can cancel from numerator to denominator. Okay, just like we did a while back. So there's 1x down there, 7 up there, so we're left with 6 on top. If we just subtract those, right, 7 minus 1, and then 4 minus 3, we're left with y to the first power, or just y. So this expression simplifies to that. Okay, next one. So we're not going to pause the video on this one, we're just going to kind of work through it together. So I'm not going to work with cross-canceling anything. There are no coefficients, so we're just going to go straight from left to right with our variables. Okay, so x squared, and don't forget that's exponent of 1 if there's nothing there. So we'll have x to the third on top, and then we'll have y to the sixth, 4 plus 2, and then we'll have z to the third. Okay, all we did, added the exponents for each of the variables. And then the same thing on the bottom. So I have x to the third. There's a 1 exponent for both of those. So we have y squared down there. And then z cubed. Okay. And now we're looking at things to cancel. So I have x to the third on top and bottom. That cancels out. I have z to the third on the top and the bottom. That canceled out. And then we're just going to subtract those exponents. Okay. So that would turn that into a 4. So I would be left with y to the fourth for my final answer here. Okay. So if you guys would like to, you can take a break now, and you have a topic of conversation here. You can stand up, you can stretch a little bit if you need, whatever your sub would like to do for your brain break. Your conversation topic here for about 2 to 3 minutes. Share where you went over Thanksgiving break. It might be a little bit different this year. Some people still went wherever they wanted to. Some people avoided families, so maybe people did Zoom for Thanksgiving break for a Thanksgiving meal, or maybe they did Google Meets or something like that. But this might be the better part. Share what you ate. Maybe you have a traditional family meal that you have or something like that. Share what you had for Thanksgiving. Alright, so after your break here, we want to try a couple of these. Okay, so we're going to try a couple of these harder ones, and then we're going to do some division. Okay, and then we'll be almost done. Alright, so starting off, please write these down. I recommend factoring completely. See if you can do this one. So please pause the video and then come back for the solution. Okay, so I'm going to write these down in factored form right below here. So the top right here, actually I'm just going to write it above. Let's see if I can use a different color of ink. So I can take out a 3x from these, right? If I take a 3x out here, I'll have a 1. If I take a 3x here, I will have just an x. So that's what I factor to. On the bottom here, I need 2 numbers to multiply to a 5 and add to a 4. So that's going to be 5 and 1. Positive 5, negative 1. All right, because I need a positive 4 there. Over here, just got a 3x. I can't do anything with that. And then on the top, 2 numbers to multiply to 20 and add to a 1. X plus 5 and x minus 4. Okay, now we can look for these. They're a lot easier than the last ones, I think. The hardest part is factoring here. You just look at everything on the top and then everything on the bottom. If you have common factors, then you can just go ahead and start canceling. So we have a 3x there and there cancel. You have the x plus 5 there and there that canceled out. And now you might be left with this and then that on the top, and then we'll have x minus 1 on the bottom. Okay? Now some of you might have recognized that this and this are very similar. Okay? Remember when I taught you guys to factor, you never want to leave those variables a negative. So how can I switch this variable to a positive? Well, if I take out a -1, that's going to flip that around and make that x a positive and that 1 a negative. And then you can see I have the same thing on the top and the bottom, but then there's that negative there. So then I can just put that negative right in front of the x minus 4, and if I wanted to, I can multiply that through. And this is the nicest answer for that question. Okay, so a little bit of recap for this question. We started by factoring everything, the numerators and the denominators. After we had everything factored, then we looked at the factors on the top and the factors on the bottom, and we looked for common factors to cancel out. Then, this was our second step in simplification. We saw that we had that binomial and that binomial. They were very similar, but I had to use this little trick with a -1 in order to get them to be exactly the same in order for them to cancel out. Okay? So let's try another one. So go ahead and I would review your notes for this one, okay? Because we have a cubic right there. This one actually isn't that hard, but you have to know exactly how to factor a cubic, okay? So for those of you at your table that know how to do this, make sure you help your partners understand how to factor a cubic. Remember, this was what we called SOAP patterns. Okay, so this turns into an x, this turns into a 3 because those are cube roots. And then we have x squared, and then we have a 3x and a 9. So it's same, opposite, always positive. So the bottom factors to this. And like I said, once you know how to do that, it's not that difficult because I can't factor that. And you might want to try to factor this, but there's not two numbers that multiply to a 9 and add to a 3. So that cancels with that. And we're left with x plus 2 on the top and x minus 3 on the bottom. So really it was only one step. I had to know how to factor that, and then I just canceled out these two common factors. Okay? So, division of rational expressions, so division of fractions. So how do we divide fractions? You skip, flip, and multiply. That's what we learn in middle school, right? We skip the first fraction, we flip the second fraction, and we multiply. This is a fancy way to say multiply by the reciprocal. Maybe reciprocal is too big of a word to learn in middle school. Not for sure, but this is what you learn. Skip, flip, multiply. So since we are taking this to the next level, you skip, flip, multiply, and then you factor and cancel before you multiply straight across. Okay? So we'll check out this example here. They're not too bad. If you understood the last stuff, they're not too bad. Okay? So we see we have a division sign here. So that means we need to flip this around, okay? And I'm going to do that right now. And we have x squared minus 6x. So you can see when you're looking at these questions in your textbook and you see division, before you write it down on your paper, it would be best to flip it when you write it on your paper. So I don't want to write the question out 4 or 5 times. Just want to write it out a couple times here and save myself a little bit of space on my notes. Okay, then we're going to factor. So we turn this division into a multiplication because we flipped, right? So then we're taking out a 2 down here, and then we're going to simplify this stuff here, or we're going to factor it. So 2 numbers to multiply to 30 and add to 11. That's going to be a 6 and a 5, and they're both going to be negative here because we need a negative 11. Okay. So that means they both have to be negative. And then down here, we're going to take out an x, and we'll have x minus 6. And now remember what I said before, we're going to look at the top and the bottom and see what cancels out. So I have a 7, I have an x, I have an x minus 6, and an x minus 5. Okay, so that x minus 6 will cancel out. I have an x minus 5 that's going to cancel out. Those are the obvious ones. Then I have an x there and an x there. Those are both going to cancel out as well, because those are just individual factors. Okay? So if I look at everything that I had on my top and bottom, I have a 7 and a 2 left. So this entire problem factors, or simplifies to 7 over 2. Because I canceled all those out, I canceled all those out. Okay? Like I said, if you are writing this down from your book, it might be easier just to write this down times this rather than writing the entire problem out twice. Okay? So this one, I'm going to give you a hint to start, and then I want you to try to do it on your own. Okay? So I have this fraction up top. All right, and you might want to write this one down. This is called a complex fraction. Okay, and this is a fancy way just to divide two fractions, because if you look at this, this is one fraction on top, this is another fraction on the bottom, and I just have this one divided by this one, that divided by that one. I'm just dividing two things, okay? So remember, if I'm dividing fractions, I skip, flip, multiply. So I have this one times the reciprocal of this one, okay? So I'm going to start rewriting these out, just like I said we should do. Okay, that's the top. We divided by this one, so we're going to flip this one and multiply. So 2y minus 3x over x cubed. Okay, so factor those out and then see what you can cancel. Okay, so you can pause the video here for about a minute or 90 seconds, see if we can get these things factored out. Okay. So x squared doesn't do anything, 2y minus 3x doesn't do anything, x cubed doesn't do anything. This is the one that we have to factor out. Okay, so we'll have 3x minus 2y, and then 3x plus 2y. Okay, this is difference of squares. This is a perfect square, this is a perfect square, so we have difference of squares. Okay, so if I think about just common factors, that x squared will cancel with two of those, so I'll just have an x left down there. That's in the bottom. And now this one looks really similar to this one. Okay, but we have a positive 3x there and a negative 3x there. So what we can do, if you remember that little negative rule, we can factor out a negative 1, and then it switches it around. And then that allows us to cancel things. Okay, so that will cancel with that one. And then we just need to write out what we have left. Okay, so I have a negative 1 on top, and on the bottom I have this and this, so it'll be x, 3x plus 2y, and that would be the final answer. Okay, so that's all we have left. So really the big thing here with a complex fraction, it's a fraction divided by a fraction, so you skip, flip, multiply. Same exact thing. Okay. So if you wanted more practice, I'll finish these out. If you're in class and you don't want more practice, we can skip to the assignment right there. So there's the assignment. You can pause the video there. For people that would like more practice, I'm going to go back now to the last couple examples. So for something like this, we're going to factor. Right, so I can't just start canceling stuff from top to bottom. I have a subtraction there, so that means I'm going to have to factor something to see what I can do. So on the top, I have an a to the 4th that I can take out, and then that would leave me with b minus 2. On the bottom, the denominator here, I have an a cubed there and an a cubed there. I can take that out, and I would have a 2 minus a b. Okay. So we can go ahead, cancel out some a's. There's 3 there, 4 there, so I'll be left with just an a on the top. I got b minus 2, 2 minus b. Those are very similar, so remember we're going to have to do that little negative 1 trick. Like that, and then we can cancel those out. So we have an a on the top and a negative 1 on the bottom. That just simplifies to a negative a. Okay, let's try another one down here. So we have 20x minus 5x squared. Let's go with blue here. we're going to take out a 5x, and then that will leave us with a 4 minus an x. Okay, that's kind of backwards, so let's just go ahead and be a little proactive here and take out that negative and switch things around. So this will be a negative 5x, and then that's going to be x minus 4. Down here, take out an x, we'll be left with x minus 1. Up here, two numbers to multiply to 4 and add to 3, so that's going to be a 4 and a 1. We're going to have a positive 4 and a negative 1 because we want those to add to a positive 3. And then down here, difference of squares, x minus 4, x plus 4. Now we can just start canceling stuff out. So I have an x minus 4 there, I have 1 there, x plus 4 there, x plus 4 there, x minus 1 there, x minus 1 there, and I have an x there and an x there that cancels. So everything cancels except for the negative 5. So this entire expression simplifies down to a negative 5. And we'll do one more down here. Okay, so this is a division problem. So that means we're going to flip this one and then multiply. So I'm just going to draw this. This will be my flip. And I'm going to factor these two. So two numbers to multiply to 8 and add to 6. That's going to be a 4 and 2. So I'm putting that on the top. Remember, because I'm flipping that. Okay. And then the bottom, I'm going to factor this, put it on the bottom. X, take an x out, x minus 2. And then over here, 4x stays as 4x. Over here, we can take a 5 out, x minus 4. And then we can start canceling binomials. So x minus 4 goes away, x minus 2 goes away. I have an x there and an x there. That's just a single factor. Those go away. And I'm left with a 4 on the top and a 5th on the bottom, or 4/5. Okay? So hopefully this helped you if you need a little bit of extra practice. And again, here is the assignment. Thank you for watching. Please email me if you have any questions.